All right, these substitution problems require kind of a little extra step in them. So where we have our function in a function would be right here. So we're putting that equal to u, and this derivative is easy here. It'd just be du equals dx. So if we substitute, this will turn into square root of u, and our dx turns into du. But here's the problem now. We got that x plus 2 over there, and we can't integrate with x still in there. So what you have to do on these problems is once you hit this step, you're going to have to figure out a way to get rid of that x. And we do that by manipulating this equation right here. So what we can do is figure out something, or take this substitution and change it and see what x would equal from there. So if we were to add that 1 over, we see that x would be equal to u plus 1. And so what we're going to need to do is take that u plus 1, substitute that in place of x over here, and then everything's going to be in terms of u. So now we got u plus 1 is what we put in for x, plus this other 2 all over square root of u, and I'm going to write that as u to the 1/2. Okay, so how do we proceed then and find this integration out? Well, one thing we can do for sure is simplify. That'd be u plus 3 on top. Okay, but now we get to this step, and this can be kind of confusing sometimes if you don't know what to do. So you hit here, but what's the antiderivative of that? We can't just find antiderivative both the top and bottom separately. That would be incorrect. It would not be equal to something like this. That's wrong. So what we have to do is try to simplify this integral first, then find the antiderivative. And what I mean by that is we can separate this into two separate fractions. So we can think of it as u over u to the 1/2 plus 3 over u to the 1/2. So we take that common denominator and just split it up into two separate fractions. That's still equal to what was above it. Now what you're going to do is continue to simplify here before we do this antiderivative. So if we got u to the first power, u to the 1/2, and we subtract those because we're dividing, that would just be u to the 1/2. The second one, there's no simplifying, but I'm going to move that u up to the numerator, so we switch it to a negative 1/2 there. Now that's an integral we know how to find. So find the antiderivatives, and we should get to the solution here. Going up from 1/2 would be 3/2, reciprocal is 2/3. Here going up 1 would be 1/2, reciprocal is 2, times by 3, that would be 6, plus some constant. Now if we substitute back in, we have it, and our substitution was x minus 1. And so we end up with 2/3 x minus 1 to the 3/2 plus 6 x minus 1 to the 1/2 plus, and there would be our antiderivative. Let's have you try one of those out. Pause the video and see if you can solve this one. All right, let's see what you got. You should have picked u to be this because that's what's inside the other function. Derivative on this one, again, is pretty simple here. But we are going to have to, like the last problem, manipulate this one. So this becomes square root of u, this becomes du. We have to substitute something in for that extra x though. So if we play around with this equation and add 3 to the other side, looks like x is going to be equal to u plus 3. So that's what we need to put in place of that x right here. So we'd end up with u plus 3 plus that extra 5 there. That was already there. So what we have now is u plus 8. And again, I'm going to write square root of u as u to the 1/2. So this one didn't require you to get separate fractions, but it is going to require that you distribute. So hopefully you distributed there. That when you have power timesing, that you add the exponents, so it'd be 3/2 plus 8 u to the 1/2. And now you can find the antiderivative to get our answer. That'd be 5/2 if we add 1. Reciprocal is 2/5. Here it would be 3 halves. Reciprocal is 2/3. And then plus our constant. Now substitute back in, and our substitution here was x minus 3. So we get 2/5 x minus 3 to the 5 halves. Plus, I'm going to multiply those together. 16/3 x minus 3 to the 3 halves plus c. So if you had that, great job.